everyone, very good evening. I welcome you all at India's most comprehensive preparation platform for all competitive exams, that is BYJU'S Exam Prep. So guys, this is a YouTube plus app series. In this particular series, I will discuss the concept on the YouTube. Then we'll have the practice in the form of quizzes at the application. So you just need to register at the app using your number. You don't need to do so many things. The link is already in the description for the application. So just register using your number and you will be able to participate in the quiz. That quiz will start at 10:15 p.m. after this session. So in this session, what are we going to do? In this particular session, we are going to discuss or cover all the concepts of relational algebra, right? So let's check. This is a brief introduction of myself. My name is Vishal Rawatiya, 10 plus years of teaching experience. These are the achievements and areas of expertise. Okay. Apart from that, there's an announcement for all of you that BYJU'S Exam Prep is going to conduct a national scholarship test for all GATE aspirants tomorrow at 9 a.m. Do participate in this test and you may avail up to 90% off on all our programs. So let's try to understand. Are you all here? So please, if audio video is clear, then please let me know, because this session will be conducted on app as well as on the YouTube. Therefore, this is a new thing for me. So please confirm if audio video is clear. Kindly confirm if audio video is clear so that we can proceed. So what is relational algebra? So relational algebra is a procedural query language. So when I say procedural query language, then you need to understand that to retrieve the data from the database, we will define a procedure, and using that procedure, we will be able to access the data from the database. Now, this is generally a theoretical foundation for all relational database. Even if you use SQL, then the concept of SQL or implementation of SQL is eventually based on this theoretical concept of relational algebra. That is, if you want to understand SQL in a better way, then you must know the concept of relational algebra. Clear? Now, let's see. What are the different relational algebra operations? So there are two types of operations in the relational algebra. One are basic operations, which can be used directly, and another are derived operations. These derived operations are derived using two or more or one or more basic relational algebra operations. Guys, kindly confirm if audio is clear. Kindly confirm. Right? So let's move further. So what are the operations? Basic operations are selection, projection, cross product, rename of the relation as well as attribute, union, and set difference. This intersection, people generally think that this is a basic operation, but intersection is derived using set difference. Intersection will be derived using set difference. So join is very important. In the previous session itself, I have told you that this join operation will be used for the relational algebra as well as to understand the concept of normalization, because when we decompose a relation, we need to ensure that the decomposition of the relation is lossless joint decomposition. Clear? And we will also see division. So let's see. So selection. So why do we use selection operation? Selection operation is used to select the tuples on what condition? So along with the selection operation, we will define a predicate condition. So from the relation R, based on this predicate condition, tuples will be selected, right? So let's assume, if we have SID, S name, and let's say CID, right? So SID is S1, name is A, S2, name is A, S3, name is B, and the course IDs are C1, and C2. So let's see, if I say, let's assume the name of this relation is R for the simplicity purpose. So if I say select from the relation R, so what are we doing? Select, this is the selection operation. From the relation R, what is the condition? Let's say that S name is equals to A. So you will select the tuples from this relation in which S name is A. So these are the two tuples in which S name is A. Therefore, these two tuples will be selected. Clear? So you will get this. Clear, clear, clear. So these two tuples will be selected. Now let's say that these are S1, A, C1. Other things will be clear at the later point of time. S2, A, C2, or let's say C1 itself. Clear? Now let's move ahead. This is the selection operation. You can define any condition. So you can also say one or more condition can also be defined. So you can say S name equals to A or S name equals to B. So if I want to say that S name equals to A or CID equals to C2. So if I say so that CID equals to C2, then this tuple will also be selected, because in this, though S name is not A but CID is C2. So you can define one or more condition with the selection operation. Clear? So don't think that there should be only one condition. No. Now what? So if this is OR, then all these tuples will be selected. Now tell me, if this operation is not OR but AND, so this with respect to first one, these are the tuples which will be selected. With respect to second one, all the tuples of this relation R will be selected. In the third one, when it is AND, what will be selected? So with respect to third one, the result will be 5. With respect to third one, result will be 5, because there is no tuple in which S name is A and CID is C2. Clear everyone? There is no tuple in which name is A and CID is C2. So this is selection. Next one is projection. Why do we use projection? It is used to project the column data. So it is used to project the column data from the relation based on the attributes specified with the projection operation. So along with this projection operation, you will define the name of attributes and the columns, the data of the columns corresponding to this attributes will be projected, right? So let's see, in the previous selection, example itself, if I say that project SID from relation R, what will be the output? If I say project SID from the relation R, what will be the output? So the output will be, you will have only one column in the output which will be corresponding to the SID. Previously, when you did not project anything, all the columns will be produced. But if you are selecting that only a particular column should be produced, then the remaining column will not be selected. Now the idea is the result will be S1, S2, S3. If I ask you that pi CID from relation R, what will be the output? So with respect to CID, the output will be what? Sir, there are two tuples in this column CID in which CID is C. So tell me whether you will get C1, C2 or you will get only C1 and C2. So you will get only C1 and C2, because by default relational algebra query will produce distinct tuples. There will be no duplicate tuples. There will be no duplicate tuples. Clear? This is this projection, right? So you can use projection along with the selection. So you can actually do what? You will have some selection condition. You will define your predicate condition. You will define the relation, and from this you can define some columns with respect to which you want to produce the output. So this is projection. Third one is cross product. What is cross product? Sir, cross product is a binary operation. Earlier, it is a unary operation. Only one relation is needed. It is a binary operation. Let R and S are any two relations, then the cross product of R cross S will result in all attributes of R followed by all attributes of S with all possible combinations of tuples from R and S. So let's assume if I have a relation R in which there are three attributes A, B, C and another S with attributes C, D, E, and let's assume the tuples in this relation are 1, 2, 3, 2, 2, 3, 2, 1, 4, 3, 1, 2, 2, 2, 3, 3, 1, 2. So if these are the tuples, what will be the output of R cross S? In R cross S, what did I say? You will have all the attributes of R followed by all the attributes of S. So you will eventually have 6 columns. You will have R dot A, then you will have R dot B, then you will have R dot C, then you will have S dot C. So C is appearing twice. One is with respect to relation R, another with respect to relation S. So S dot C, S dot D, and S dot E. Now what will happen with all possible combinations of tuples of R and S? So with the first tuple of R, that is 1, 2, 2, will be combined with all tuples of S, that is 3, 2, 3, as well as 1, 2, 1, as well as 2, 3, 2. Right? Similarly, so here this 3 values will be same. Similarly, 2, 2, 1, that is the second tuple of relation R, will also be combined with all the tuples of S. Similarly, third tuple 3, 3, 4 will also be combined with all the tuples of S. So, what did we learn? What did we learn? So, if R has X attributes, and S has Y attributes, then in R cross S there will be X plus Y attributes. There will be X plus Y attributes. If R has M tuples and S has N tuples, then each one of this M tuple will match with N tuples. Therefore, in R cross S there will be M into N tuples. Clear? Is this clear to everybody? This is your cross product. Now, let's move further. One is rename operation. So that's a simple operation. It is just used to rename the relation or the attributes of the relation or both, right? So if you simply want to rename, let's assume that you have a relation student. You want to rename this student with S. So you can simply say row S with student. So this row is used to represent the rename operation. Now let's assume that student is a relation in which there are 3 attributes: SID, SName, and let's assume roll number, or roll number. Fine, it's not a problem. So if you want to rename the attributes, then you will say row. Then let's assume you want to say ID, name, and roll number from the table student. Then in this table, from now on, SID will be known with name I. The first attribute of student will be known with name I. The second attribute will be known with N, and the third attribute will be known with R. So you can rename the table as well as attribute, and you can rename both as well, right? So this is okay. Apart from that, set operations. Sir, what are these set operations? These are the 3 set operations: union, set difference, and intersection. But can we apply the set operation all the time? No, sir. Set operations can be performed only if relations are union compatible. So let's assume there is a relation R which consists of 3 attributes A, B, and C, whereas there is another relation S which consists of only 2 attributes C and D. Then can you perform R union S? No, sir, not allowed. Not allowed. Why? Because these are not union compatible. For them to be union compatible, what is the idea? Both the relation must have same number of attributes. If there are 2 attributes, then there are also in S also you should have 2 attributes. Apart from that, the attribute domain, that is the values which are being taken by the particular attribute, must be same. Well, not exactly same, the domain must be same. These are the values which are taken. So let's assume if A is taking the integer value, let's assume that C is not present for time being, that is the number of attributes are same. But if this C is taking the string value, then you cannot perform the union operation, though the number of attributes are same, but the domain is not same. So for the union, set difference, and intersection to be performed, what's the idea? For union, set difference and intersection to be performed, the number of attributes should be same, and the domain of the corresponding attribute should also be same. So first attribute is integer here also the first attribute should be integer. Second is character here also the second should be character. That's the idea of set operation. Now What is intersection? How do we perform intersection? So we said union and set difference. You already know what do you mean by union and set difference. We have already discussed in these sets. So if you say R intersection S, what is R intersection S? R intersection S is a derived operation which is derived using set difference. So it will be nothing but R minus S. You can actually see, so this is your relation R. This is your relation S. So what is R? This complete thing is R. So this is R. Now, this thing is R minus S. This thing is R minus S. This shaded region is R minus S. So R minus S. So from R, if you subtract R minus S, you will be left with this. This is actually nothing. This red color region is nothing but R minus S. Clear? So this is actually a intersection. This is actually a intersection. So these are the basic relational algebra operations. We have discussed all the basic relational algebra operation. We have also discussed the derived relational algebra operation. Clear? Now move to the more important operations, which is join. Right? The operation is join. There are various types of join operations. The basic join operations are natural join, conditional join, and outer join. How do we derive the join operation? So let's try to understand with respect to natural join. This is most important. Why? Because this will be used here as well as it will be used in the normalization process. So sir, what is natural join? So R natural join S, if you are trying to derive R natural join S, then R natural join S is derived operation which is derived using first obtain R cross S. First, you need to obtain the cross product of R and S. Second, you need to select the tuples based on the equality condition on the common attributes from R cross S. From R cross S, select the tuples based on equality condition on common attributes and third is you need to project distinct attributes from R and S. Project distinct attributes from R and S. Clear? So let's assume if R is a relation which consists of attributes A, B and C, and S is a relation which consists of attributes C, D, E, then what will be R natural join S? R natural join S will be derived using what? First, you need to calculate the cross product of R and S. Then from this cross product, so we have learned how to calculate the cross product, all the attributes of R followed by all attributes of S with all possible combinations of tuples of R and S. So first you need to calculate this. Then what? From R cross S, select the tuples based on the equality condition. So now you need to use the selection operation. What are the attributes which are common? The common attributes between R and S is C. So therefore you will have to say the value of R dot C should be equals to the value of S dot C. Value of R dot C should be equals to value of S dot C. So from here the tuples will be selected. From those selected tuples, what you need to do? You need to project the distinct attributes of R and S. So A, B, C is duplicate. So you need to project C only once, D, E. So you need to project A, B, C, D, E, and you will get your natural join. You will get your natural join. Clear enough? Now, sir, this is one case. What if there are more than one common attribute? So this is also fine. If there are more than one common attributes, let's say B and C are common between both R and S, then the only change that will occur is that the selection operation will be based on the equality condition on all common attributes. So what's the idea, sir? R dot B should be equals to S dot B, and C is also common, therefore R dot C should be equals to S dot C in relation R cross S, and from there you will project the distinct tuples, and this time the distinct tuples will be only A, B, C, D. Distinct tuples will be only A, B, C, D. Clear? Guys, is this clear to everyone? Now, there may be a situation when there is no common attributes between R and S. So, the third scenario, when there is no common attribute. So, R is AB and S is something CD. So, if there is no common attribute, then this condition will not occur. So, in that case, you will not have this R cross S, then you will select all the attributes A, B, C, D. So, you can actually see that in this particular scenario, R natural join S will be equals to R cross S only. R natural join S will be equals to R cross S only. That's the idea, right? So, this is a natural join. In natural join, what is the difference between natural join and conditional join? What is the difference between natural join and conditional join? In natural join, by default condition, if you are not writing anything here, you are simply saying join, 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 then this will be natural join. And natural join, by default condition, will be equality condition on the common attributes. If you are saying conditional join, then you can define the condition explicitly. Let's try to understand that for this relation R, which is A, B, C, and S, which is B, C, D, you can eventually have a conditional join in which you will say R, the join with S, but this join should be based on the condition that the value of B in R should be less than value of D in S. So it can be any condition. It is not necessary that the condition should be applied on the common attributes. Condition can be applied on any, the condition can be anything, right? So this is nothing but your conditional join. So whatever the condition is, based on that you will select the output. Now apart from that, left outer join. How do we denote left outer join? Left outer join is denoted using this symbol, dumru. On that there will be some arrows on the right side. Right outer join, this arrows will be in the right hand side, and full outer join will have this as well as this, right? So if we try to understand outer join, so left, right, it will have some meaning, right? So when I say R left outer join, so which one is the left relation? Sir, R left outer join S will be nothing but R natural join S. You will have all the tuples of R natural join S plus the tuples of R tuples of left relation which failed join condition. Which join condition? Natural join condition. Which failed join condition. Right? If it is right outer join, so it will be, which one is the right side relation? S. So it will be same R natural join S plus tuples of right side relation. Tuples of right side relation which failed join condition. Right? Sir, what will be full outer join? So it will be full outer join. So this is, so there is nothing directly. Full means left as well as right. So you will have, this will be R natural join S plus tuples from both left and right side relation. Tuples from both left and right side relation. Which failed join condition. Right. So let me give you a simple example. Yeah. Let's try to understand the natural join or outer join. So let's assume that if R is a relation, which consists of two attributes A, B, let's have only two attributes, The values are 1, 2, 3, 4, and S is a relation which consists of two attributes B and C, and let's assume the values are 2, 5, 6, 2, whatever, right? So what will be R natural join S? So when you calculate R natural join S, what will happen? 1, 2, equality condition will match with this, so R natural join will have only A, B, C. In this you will have tuple 1, 2, and this 2 will be equal, therefore 2, 6 will match, but this 4 is not equal to any B, therefore it will not match with any tuple of S. Similarly, this 5 is not equal to any B in R, therefore this tuple of S will not match with any tuple of R. So this is your natural join. This is your natural join with respect to A, B, C. But if you are trying to calculate left outer join, so if you are saying R left outer join S, then what will it be? Sir, you will have tuples, you will have attributes A, B, C, you will have the tuples from natural join, that is 1, 2, 6, and apart from that you will have the tuples from left side relation, that is R, that is 3, 4, which failed the join condition, and in C you will write null. In C you will write null. Similarly, so now I hope it's clear that if it is R right outer join S, then you will have the tuples from natural join, that is you will have 1, 2, 6, and then you will have the tuple from the right side relation, that is 5, 2, which failed the join condition, that is 5, 2, but this time this will be null. A will be null. In full outer join you will have this 1, 2, 6, as well as you will have this tuple, as well as you will have this tuple. So full outer join is the union of both the outer joins. No problem. Clear? So this is the natural join. I hope you have understood the concept of natural join. Now comes the next derived operation, that is division. So how do we, what do you mean by division? So division is used. Division is used for every and all type of queries. Let's try to understand this with the help of an example. This is very important because most of the times the questions are asked which are similar to this concept. So let's assume that we have our table enroll. We have our table enroll in which we have SID and we have the information of CID, that which student has enrolled for which course. So, and let's assume that there is a table course. For the ease of writing the query, I'll denote enroll by E, I'll denote course by C. Right? It will have two tuples, CID and let's assume C name, whatever it is. Right? So it will be C1, C2, C3, name may be OS, DM and AI, whatever. Right? Now let's see that what is the enrollment. So S1 has enrolled for C2, S2 has enrolled for C1 as well as C2 as well as C3, right? And then S3 has enrolled for C2 only. Let's assume this is the situation. So if I ask you that retrieve the SIDs of the students who enrolled for some courses, so let's try to understand. There may be another table. There may be another table, let's say a student, and this is S, right? And it has SID and S name. So is it necessary that all these students enroll for some courses? It may be possible that some of these students did not enroll for any course. S1, S2, S3, S4, these are the information about the students A, B, B. So that's fine, right? So if you project the SIDs from the student, then you will get the SIDs of all the students in the university. If you project the SIDs from the enrollment table, then you will get the SIDs of the student who enrolled for some courses. But my question is, retrieve SID of the student who enrolled for all courses. What is my question? Retrieve SID of the student who enrolled for all courses. What will be the answer? Retrieve SIDs of the students who enrolled for all courses. So the moment you see this all, you need to think in terms of division. The moment you see this all, you need to think in terms of division. The answer for this will be that you can eventually project what two informations are needed, SID and course. So let's try to understand what how do you define the courses. So the courses are defined with respect to CID. Now let's try to understand. There may be some other columns in this enroll table. Let's assume P. There may be some other column which are free, but you are only interested that with respect to what SIDs all the CIDs of course table are available. With respect to what SIDs in the relation enroll, all the CIDs are available. So you will say that from this relation enroll, which is denoted by E, from this relation enroll E, project only two things, SID and CID, and divide it from the table course. See, we are only interested in the CIDs. So this will be pi CID from course. So you are actually looking for the tuples in the enrollment table in which the SIDs are such that corresponding to them all the CIDs of course table are available. But how actually this is derived? The main question is that how actually this division is derived. That's what we need to learn. So, sir, let's assume, let's try to understand what am I trying to do. There is no direct way of writing this query. You will have to derive it. You will have to derive it. Sir, how do you derive this? So let's try to understand. If I say that pi, let me change the color. And let's try to understand this. This is most important. If I say pi SID from table enroll, then you will get what? Sir, the result will be, let's look at the table. Sir, you will get S1, S2, S3. You will not get S4. You will get pi SID of E will be S1, S2, S3. So this is students who enroll for some courses. This gives me what? Try to understand this. Students who enrolled for some courses. There is no direct way of doing this. We are defining the process, right? So this is what pi SID E will be. Now, if I ask you second thing, that pi CID from relation C, you will get what? Sir, you will get C1, C2, C3. List of all courses. List of all courses. Got the idea? Now what I'm saying is that do one thing, that just cross product this students who enrolled for some courses with the CIDs or the list of all courses. What will it be? Sir, here this S1 will be matched with C1. Let me write this. So S1 will be combined with C1. S1 will be combined with C2. S1 will be combined with C3. S2 will be combined with C1. S2 will be combined with C2. S2 will be combined with C3. S3 will also be combined with C1, C2 and C3. Right? So, sir, what is being produced by this? This is something a universal set. This is what set it is, a type of thing which is a universal set. What do I mean by universal set? That is when all students enroll for all courses. So every student of E, every student from table E enroll for all courses. So this is a scenario. Now let's try to understand from this. If I subtract from the course E, so what are the information available in the course? What are the information which are available in the enroll table? Enroll table tells you that who has enrolled for what courses, who has enrolled for what courses. So we are not worried. We are not worried about this fee. We are not worried about the fee. So you just need to select that. What if we select SID and CID from this table enroll? Then if we subtract the tuples of enroll table from this universal set, then what will happen? After this subtraction, you will be left with only those tuples which are not corresponding to all CIDs. So let's try to understand that here the student S2 has enrolled for all the courses. Here also S2 is matched with all the courses, therefore all the tuples will be deleted. But in this scenario, S1 is enrolled for only course C2, therefore after this subtraction you will be left with S1 C1 and S3 C3. Sorry, S1 C3. S1 C3. S2, the information of the S2 will be deleted completely. Then S3 has enrolled only for C2, S3 has enrolled only for C2. Then again for S3 as well, you will have the tuples S3 C1 and S3 C3. So here you will have the information of students who has not enrolled for all the courses. This gives you this subtraction. This is the result of this subtraction. Okay, don't get it otherwise. This is the result of this subtraction. So what will you get from here? You will get, it will contain the information of the students it will contain the information of students who did not enroll for all courses. Who did not enroll for all courses. So from this relation in which you are having this tuples in which the information of a student is available who did not enroll for all courses, from them you project the SIDs. From them, if you project the SIDs, then you will get the SIDs of the student who did not enroll for all courses. SIDs of students who did not enroll for all courses. Right. So this relation will give you the SIDs of the student who did not enroll for all courses, and you are having the SIDs who enrolled for some courses. So this is by SID comma E. This is the same thing. This is the same thing. So here you will have S1, S2 and S3. From here when you will project SID, you will get only S1 and S3. From here you will get only S1 and S3. Right? Now what will happen? When from all the SIDs of the student who enrolled for some courses, if you subtract the SIDs of the students who did not enroll for all courses, then this subtraction will give you the SIDs of the student who enrolled for all courses. SIDs of students who enrolled for all courses. So this is how your division is derived. So if you want to derive pi SID comma CID from table enroll divides with pi CID from course, then this is what eventually happen inside the query processor to produce your output. Got it? So this is the derived relational algebra operation, and this is how the division is derived. Clear? So I hope you have understood all the operations now. Now we know all the operations. What, sir? Selection is used to select the tuples. Projection is used to project the output corresponding to specified attributes. Cross product will combine all the tuples of one relation with all the tuples of another relation, in which all the attributes of both the tuples, both the relations will also be available. Rename is just a simple thing which is used for the purpose of renaming. Set operations will be can be applied only if the relations are union compatible. So remember these two properties, that if these two properties are not satisfied, then the set operation cannot be performed. And intersection is derived operation which is derived using set difference. That's another thing. Now join, various types of join. Natural join, in which the condition is predefined that it will be equality condition on the common attributes. If you are trying to define with a condition, then the join can be performed based on any condition. The join can be performed based on any condition. You can define any condition, whatever you want to join the tuples of two different relations. Right? Apart from that, you can have the outer joins. There will be left outer join, right outer join, and pull outer join. Then division is also known to us. The division will be used to produce the output when the query is asked for every or all. When the query is asked for every or all. Got the idea? So this is division. This is it. So we have discussed all the types of operation which we have defined, whether basic or derived. Now let's try to understand. This is an example. This is an example. This is actually a question from GATE 2009. So I am not discussing the question. I am just trying to choose these relations to explain you certain things. What are the things which you are trying to explain? So whenever you try to solve a problem, you need to analyze that what information is available in which relation. If you don't know that the information is available at what place, the information which is required by you is available at what place, then how will you retrieve the data? So first you need to analyze that what are the informations which are available in the different relation. Right? Now, sir, the very important thing is that why do we perform this cross product? Why do we perform this cross product? So we perform this cross product to merge the tuple of one relation with the tuples of another relation. The problem with any query is that the query machine will process on only one tuple at a time. The query will process on only one tuple at a time. So if you want to compare one tuple of relation R with one tuple of relation S, or if you want to compare one tuple of relation R with some another tuple of relation R, then you cannot process a query, or the query cannot work on two different tuples of the same relation or two different tuples of two different relations. So before you execute that, you will have to combine the tuples of relation R with the relation tuples of relation S if you want to execute the query based on one information is specified in tuple of relation R and one information is specified in tuple of relation S. If you want to compare two tuples of the same relation, then you will have to perform the cross product of the same relation, that is self cross product. You will have to perform the self cross product, right? So that's what you need to understand. Now let's try to understand that. Let's assume that this is your scenario. So what do you observe from here? There is a relation suppliers which has the SID of, so it's a primary key, so it will eventually have the information of all the suppliers. Then this is a part. So here this PID is the primary key. It will contain, this part table will contain the information of all the parts. Then there is a catalog in which SID and CID together are forming the candidate keys. What does it mean? That one SID can be corresponding to multiple PID and one PID may be corresponding to multiple SIDs. Got the idea? So here SID and PID together are forming the key, means the set wise the values of SID and PID will be unique. So if you are saying S1 comma P1, then this S1 comma P1 will not be available anywhere else in the catalog, because these two are key, therefore those values cannot be duplicated. Those values cannot be duplicated. That's what we understand from here. Now let's try to understand that what's the point. So let's assume a scenario in which you have supplier is the information of all the suppliers. So let's assume supplier table. In the supplier table you are having the SIDs S1, S2, S3, S4 and so on, along with the other information, right? And in the part table, you are having the information of PID, and let's assume the information, so the information of part name as well, but I am concerned with the information of the color, that you are having the colors of part, right? So there is one part P1, there is another part P2, there is another part P3. This is a red color part, this is a green color part, and this is also a green color part. This is a scenario, right? So this is the story. So, and let's assume that the table catalog is also available. In this catalog table, we'll have the information about SID, PID and cost. So what's the idea? Let's assume that the supplier S1 has sold this part P1 at 20 rupees. This supplier S1 has sold this part P2 in 30 rupees. Supplier S2 has also sold this part P2 but at 40 rupees. What's a margin? He is trying to earn more. And supplier S2 has also sold this part P3 at 30 rupees. So this is the scenario. If I ask you that retrieve SID from the catalog, so if I give you this SID from the catalog, what do you have? Sir, you will get the SIDs of the suppliers who have supplied some parts. If you do this, you will get the SIDs of the suppliers who have supplied some parts, whereas if you project the SID from the table supplier, then you will get the SIDs of all the suppliers. So if somebody asks you the SIDs of the supplier who have supplied some parts, then you need to understand, looking at this table, that okay, the SIDs of the suppliers who have supplied some part, information about them will be available in the catalog table, and the information of all the suppliers will be available in the supplier table, and this is the information of part. Now here we have the information that who has supplied what part, but we don't have the information about the color of that particular part in the catalog table. The color of that particular part is available in the part table. So my question is, if I ask you that retrieve the SIDs of the supplier, retrieve SIDs of supplier who have supplied some red color parts, then what will be the output? Some green color parts. Let's say green color parts. If I ask you for the SIDs of the suppliers who have supplied some green color parts, how will you do it? Sir, the supplier has supplied a part, the information of that particular thing is available in the catalog, but the color of that part is available in the part table. Color of that part is available in the part table. So you can do this thing in a way that you want to combine, you would like to combine the tuples of catalog from the tuples of part, because if you don't do it, then you cannot compare this tuple with this tuple. So here it is saying that supplier S1 has supplied the part P1, but we don't know the part color of part P1. Therefore, we need to check in the part table that what is the color of part. So what will you do? Sir, you will eventually make the cross product of catalog with part. So let me just write C and P for the ease of writing. You can use the rename operator. This is C, this is P. Right? Now, from this, what should be the condition? From this, what should be the condition? So first thing is that supplier must have supplied that part. So first thing is the C.PID, or I would say C.PID. So if supplier S1 has supplied P1, so when this tuple S1 P1 will match with this P1 red, then it's useful. But when this tuple matches with P2 green, then it is of no use, because the part of color P2 is of no use because supplier S1 has not supplied that part P2 in this with respect to this particular tuple. So what will happen? You will say in the catalog table, whatever the PID is, that same PID should be with respect to part table. So C.PID should be equals to P.PID, and we'll select that tuple only if the color of that part P1 is green. So the next thing is P.color in the part table, the P.color should be equals to green. If it is satisfied, then only we will select that tuple, and from the selected tuple you need to project the SID. From the selected tuple you need to project the SID, because that will be the SID of the supplier who has supplied some green color part. So with respect to S1 P1, you will check this is of red color, P1 is of red color, therefore this tuple will not be selected. S1 P2, so P1 will be combined with this as well, so it will come to know that okay, P2 is of green color, therefore this tuple will be selected. Now S2 P2 will be combined with this P2, therefore S2 will be selected. This S2 P3, this P3 is also of green color, therefore this will also be selected. But in the projection, the relational algebra query will produce the distinct tuples, therefore S2 and S3 will be projected only once. S2 and S3 will be projected only once. Right? Now, this query can be improved. This query can be improved. We are actually looking at the thing that C.PID is equals to P.PID. What are the common attributes between catalog and part? So, the common attributes between catalog and parts are PID, and you eventually want the equality condition of them. So, the same query can be written in a different way, that you can say that just do the natural join of catalog and part, because of that natural join you have already define this equality condition. From this you only need to select the tuples. From that you only need to select the tuples in which color is actually equals to green. Color is actually equals to green, and from those tuples you need to project the SID. This another way, but you just need to understand. So sir, this one, this least sufficient, this first one, this second one, we can do it in another way as well. Sir, here we are combining all the tuples of part with all the tuples of catalog, whereas we are not interested in the parts whose color is not green. We are not interested in the parts whose color is not green. So you can actually say that first select the tuples from the parts in which color is green, and then do the natural join of that particular thing with the catalog table, so that PID will be equal, and from there simply select the SID. So all these things are equivalent. All these things will produce the same result. First, second or third, all of them will produce the same result, but the only difference will be in terms of efficiency. The most efficient will be third one, second one will be comparatively less efficient, and first one will be least efficient, because it is trying to combine all the tuples of catalog with all the tuples of part. So that's one thing. Sir, let's look at another problem. Let's look at another problem. If I ask you that retrieve SID of the supplier, retrieve SID of supplier who have supplied at least two parts, what will you do? At least two parts. So if a supplier has supplied at least two parts, corresponding to that supplier, there will be two tuples in the catalog table. Now let's assume, let me write one more supplier S3. Let me write one more supplier S3 who has supplied only part P2. or let's say only part P1, right? So you can actually see, sir, S3 should not be selected because he has supplied only one part, whereas S1 has supplied two parts as well as S2 has supplied two parts. So how do we write it in the query, relational algebra query? Sir, to write this, you just need to do one thing, that you want to compare the tuple of one tuple of catalog with another tuple, whether in those two tuples SID is equal or not. In those two tuples SID is equal or not. So the query will work in a way that you want to compare the two tuples of the same relation. Therefore, this time you will perform the catalog with cross product with catalog. Let's say C1 and C2. One is renamed as C1, another is renamed as C2. Now, in this the condition is that you will say that I am only interested if the SID is same, because anyway this S1 will also be combined with S2, but we are not interested in this because we are checking whether S1 is appearing twice or not. So, we'll simply say that the condition should be that C1 dot SID should be equals to C2 dot SID. Good enough. But is it sufficient? No. Is it sufficient? No. Why? Because one scenario will be when this tuple S1 P1 20 will be combined with S1 P1 20, will be combined with S1 P1 20, and in that case SID will be same. But this is corresponding to the same part. So in the tuple of cross product, SID should be same, but PIDs must be different. Then only we will be sure that okay, for the same supplier there are two different PIDs, and you will say C1 dot PID should not be equal to C2 dot PID. If such a tuple is found, then in that tuple whatever the SID is, because both the SIDs are same, so either you can choose the SID of C1 or you can choose the SID of C2. You will get the SID of the supplier who has supplied at least two parts. Similarly, if you want to do it for three parts, what will you have to do? For three parts, you will have to do the cross product three times. Why? Because you want to check three tuples at the same time. Got the idea? Sir, what will be the condition now? Here the condition will be that C1 dot SID should be equals to C2 dot SID and C2 dot SID should be equals to C3 dot SID. Now let's try to understand, if CID equals to C1 dot SID is C2 dot SID and C2 dot SID is C3 dot SID, then by transitivity this two will be C1 dot C3 will also be equal. And you need to make sure that in this three tuples PID should be different. So you'll say C1 dot PID should not be equals to C2 dot PID and C2 dot PID should not be equals to C3 dot PID. Now tell me whether we need to write, whether we need to write C1 dot PID is not equals to C3 dot PID or not. What am I writing? C3 dot PID. C3 not equal. C1 dot PID is not equal, right? And there will be an and in between, C3 dot PID. Yes, it is necessary. Why it is necessary? Because if C1, let's assume it is A, C1 dot PID is A, C2 dot PID is B, right? And C3 dot PID is also A. So C1 dot PID is not equals to C2 dot PID. C2 dot PID is not equals to C3 dot PID. But C1 dot PID is equals to C3 dot PID. So to avoid this, for not equal condition, you will have to check it explicitly. You will have to check it explicitly. So if this condition is true as well as this condition is true, then you have found a tuple in which SID is same, but there are three different parts corresponding to that supplier. So you will simply project the SID. You will simply project the SID either from C1 or C2 or C3. It is not important. Clear? So these are the different things which you will have to understand when you are looking into the relational algebra, and when do we need to perform the cross product, of what relations which we need to perform the cross product. So if you want to compare the tuple of supplier with the part because the information of the color of part is available in the part table, whereas supplier has sold that part is available in the catalog table. Then you will cross product the catalog and part. When you want to check whether the supplier has supplied two parts, so you want to see whether the S1 is same and PIDs are different or not, then you want to check one tuple of catalog with another tuple of catalog, therefore you will multiply the catalog with catalog. If you want to compare three tuples, then 3 times multiplication. If you want to compare 4 tuples, then 4 times multiplication, and so on. Clear? So this is it with respect to relational algebra. We can have some more concept, but I guess this will be enough for this particular session. Now we will discuss the questions on the relational algebra. We will discuss the questions on the relational algebra on the application. So this will be available in the form of quizzes. Just try to solve the question and try to give your answers whether you have understood the concept of relational algebra or not. So please do attend this session and try to give your answer.